So what I want to present is Doom, which is a way of doing reinforcement learning in a I can't say realistic environment, but it's a game environment that resembles games that people play with. Well, it's a bit like CS, but kind of a little bit older. So the steps that we will need to do. So there's a website, right, which is the VizDoom website, which is kind of on the screen, but let's just resize that somewhat. Yeah, that's that. Yeah, so there's a website, right? vizdoom.cs.put.edu.pl. So it's some guys in Poland that have made an AI reinforcement learning environment based on Doom. So it's really easy to install. It's crazy to install. They produced an example that's really easy to follow. So basically, it's going to install it and then run the simple example. And it's crazy easy to install. So actually, I already installed it. It was probably not ideal for this tutorial. But when I installed it, because I'm on a Mac, I had to do brew install, and then I think it was SDL2. Otherwise, it wouldn't work properly. So it's not going to do anything because it's already installed. But just kind of at least entering the command. If you're on Linux, you probably still need SDL2, but might be slightly different to install. And now what I'm going to do is I use Conda. So I'm going to create a Conda environment, and then I'm going to try installing the VizDoom into the Conda environment. Updating Homebrew. I thought that would be faster because I already ran it, but apparently not. So I guess I'll probably end up get this bit later or something. I don't know. But for now, it's running. Okay, there we go. So SDL2 is the package for brew. Then let's create a Conda environment. Alright, so I'm going to use this to create a Conda environment. So I'm just creating a new root environment, and I'm calling that environment VizDoom env. You can actually create sub-environments in Conda, but I always just create a root environment, so I find it easier. But I guess there's different ways of doing it. So I'm creating a brand new environment, so hopefully it's going to exactly reflect how things are going to work. So I'm using Python 3.6.1. So let's source that. And then once that's done, we're just going to do the pip install VizDoom, which, like, if you go on the website, that's all you have to do. Somewhere it says how to install it. I don't remember where it says it, but it's basically just something like pip install VizDoom. We should probably Conda install NumPy first. It's probably going to take ages to install. Oh, it's a wheel. Should be okay. Cool. That was easy, right? Okay, so let's create. We're just going to create that test script and run that. Oh, you know what we need to do also is we need to clone the VizDoom repository, which I already did, but I'll do that again in a sec. So go to file, and then we need to copy in. Oh, you know what we're going to do? We're just going to. Oh no, we're going to run this example. So the Python example tutorial. Yeah, installation, so that probably has the get installed stuff. Right, shortest working example. Right, it tells us to get it from examples Python in the repository. So let's clone the repository. So click on the link to get the repository. And then we're going to go to the root of that and then clone or download. Grab that. And then I'm just going to rename it to be in lowercase because I'm kind of lazy at typing uppercase. So it downloaded a bit quicker earlier, but I guess it's kind of a busy Saturday afternoon, so the network's a bit slowish. You know what, I'm going to clone from my local copy. Okay, so I kind of took a shortcut, but anyway, so you can see the URL here, and then I just kind of cloned my local copy. So we've got this folder Vizdoom, and then there's an example here. If we go into Vizdoom, and there's something like /example/Python, and then basic. And no, I don't want that. It's too complicated. That's not was fast. Okay, so I'm basically just gonna try copying from the website. Alright, so we've got this file called test.vizdoom, and I'm certainly going to run that, and magically that's going to do everything for us. It loads the config from vizdoom/scenarios/basic.cfg. So this vizdoom is the name of the repository folder wherever we checked it out. So we need to be in the parent directory of the checkout, or else maybe change this. So I'm in the parent directory of the checkout. Right, so I cloned it into like the child of this folder of my home. So there is a vizdoom folder here. And then this has like whatever that was, scenarios. Vizdoom/scenarios, right? Cool. So I should be able to run the test script. Oh yeah, right. So the test script assumes Python 2.7, and I'm using Python 3. So we're simply going to modify that. Cool, and there we go now. Okay, there we go. It's running. So you can see like the reward here, and it's moving around. And if we look at the script, basically what it does is it just does 10 episodes. In each episode, it's going to read in the screen buffer into an image, which we can then run through our network or whatever. I don't have a network here. Make action. It just takes, so this random.choice action. So actions is up here. So it's a list of shoot left and right, and what is shoot left and right. These are basically look like they're one hot vectors over the possible actions. So I assume that the first value in the vector represents left, the second one represents right, and the third one represents shoot. If we did like all three, it would do left and right and shoot all at the same time. They're probably like the left and right shoot keys or something like that. So it's basically just going to choose one of these one-hot vectors randomly, print the reward from doing that, and then sleep. So the sleep makes it kind of slow. We can actually get rid of the sleep so it'll be a lot faster. So let's do that. And it also sleeps at the end of the episode, which don't really need. And let's go to this reward. Alright, there we go. So it's kind of super rapid, and we just get the overall result from each episode. It's going to run for 10 episodes and then stop forever. We just change this loop. And there we go. That's all set. And then we'll have to do is do the whole neural network bit. But I guess let's just try in some PyTorch and stuff. So there we go. This it looks kind of cool. There we go. And it's used in lots of papers from Daemon's as well, I think.